Hey everyone, I recently had the opportunity to run another introductory workshop about the best practices for getting your assets into Unreal Engine for LTU, or Lawrence Technical University. This workshop was completely free for all participants and was funded by Epic Mega Grants through LTU and was run fully remotely through Discord. This is a 4-part series that captures the entire workshop. The workshop covers the best practices for asset preparation using Maya and 3ds Max, and also the Datasmith workflow for Unreal Engine. Module 1 is a 2-part video series that covers the best practices of preparing your 3D models and data for Unreal Engine. Module 2 covers the 3ds Max to Datasmith workflow, and Module 3 covers the CAD to Datasmith workflow. If you found this helpful, let me know in the comments below, and I'll be happy to share more Unreal Engine content on my YouTube channel in the future. So with that, enjoy. I wanted to just kind of touch on, which was just optimizations, right? Bad normals and stuff like that here. Oh yeah, we need to make sure to go back to lit mode here. And if we go back to Maya, right, and we want to make sure we have good UVs, and if I actually turn off textured, right, if I duplicate this couch, Control D, duplicate, move this up, okay, we're going to do some nasty things to this couch, right? Because what I'm talking about is, like, this is a good couch. It's got nice UVs. It's not crazy high poly. It's got clean normals, right? So what do I mean? So if I go here and maybe we do a quadrangulate again, and then like all of a sudden, remember I said subdivide, right? If this was a subdivision mesh, watch how I can just kind of subdivide that a couple times. Now look at this. This couch is now 111,000 triangles. If you're grabbing models from online, sometimes you'll have these like high poly couches, high poly pieces of furniture, and you don't need that. You want it to look good, but you don't need 100,000 worth of triangles to make it look good, right? So I'll undo that, right? We'll kind of keep it nice and clean and optimized. There's also, you know, like remesh will like re-triangulate the mesh and everything. I'm just kind of showing you like good topology, bad topology. I'm not saying don't use remesh. It's just as an example. And then the auto retopologizing tool, no. And then, you know, there's just different. Let's see, fill hole. Oh yeah, reduce. Sorry, reduce is what I was looking for. Look at reduce now. I can reduce this by, you know, 75%. See how now things are getting nasty, right? Are looking pretty bad, right? I can maybe set it to 60, so it's it's bad, but not as bad. So now look at all this faceting. Look at all this faceting that's happening. And faceting means these hard faces, right? Because sometimes you have this, harden edge, right? If I harden edge, and sometimes you'll need to go to unlock normals. Unlock normals. There, right? Like that's bad, right? So in order to fix that, obviously, one, you may have to remodel assets or find new assets because this is pretty bad. Like this is our goal here. Nice, clean, even subdivisions. You know, topology only where we need it. Keeping things nice and optimized. All right. So, you know, the other thing is sometimes you run into this where it's called T vertices or T edges. And if you just move that, oh my God. Like Maya lets you do it, which is kind of annoying. I have never been in an instance where this has been helpful. 3ds Max is like, heck no. We're not going to let you make T vertices, T edges and stuff like that. And like sometimes you'll also like have like duplicate faces. So if I duplicate the face, but then I go back and combine the mesh without realizing I have duplicate faces, oh man, that's bad, right? All of these things, you're like, yeah, no crap, Omar, we're not going to do that. I get it, right? But sometimes you're pulling assets from online. Sometimes you're in a rush. Sometimes you accidentally hit extrude and don't realize you hit extrude and didn't undo further enough. That's, man, student, that happens all the time. I see that. you know, where people extrude and then undo and then don't realize that they didn't undo far enough, right? But anyways, you want to make sure that you spend the time having clean, optimized geometry. Okay, so overlapping faces, flipped normals. I mean, if I took this here and did a mesh display reverse, that's a flipped normal. It's pretty obvious, right? So, you know, there are things. Maya does have tools here. Let me see how it does. So I really messed this model up. And if I go to mesh cleanup, hit the settings, I can you know, I can do lamina faces sharing all edges, non-manifold geometry. Those are the T vertices, T edges, right? And then hit OK. And then basically Maya's like, hey, we're just going to separate this into a million pieces, and you're going to have to find that face and delete it. So it at least lets you know that it's in this area, okay? 3ds Max has a nice one, right? I don't know, just literally just create an object here. It's under views, it's called X view. And you can find, T vertices, right? It lets you know. See, it lets you know, hey, it's because it's a primitive. I have to convert it to editable poly. There, and it lets you know T vertices, 0 vertices, right? So, you know, and that's if you imported it into Max that way. You know, you can go to here, views, and find overlapping vertices. This is just, I wish Maya had this. I wish it did. But it's just such a nice way to, you know, like if I go ahead, something like this. And I want to detach here. And then you know, basically if I were to like select these now. Oh, I detached as a clone. Basically, yeah, we got about 10 minutes. Yeah, I want to hit this last thing. Basically, if you had bad models, it would find it, or bad surfaces, it would find it. So keep that in mind as you're prepping your models and preparing your models. You know, having high poly or bad models is really going to hit performance. That's why, like, if you go into here, and actually if I jump to this room, like real quick, if you go to here, this little drop down, you can just do show stats and show FPS. And it lets you know, hey, look at that. This thing is running at 8 milliseconds, 8 to 9 milliseconds. It's running 120 frames. I'm going to move around here a little bit. That's good. If you're doing VR, you're doing ArcViz and you're doing VR, you can't go over 11 milliseconds. And you want to be above 90 frames per second. Now, I say you can't. You sure as hell can build a VR project at 45 frames a second, but guess what's going to happen? All of the users are going to get disoriented, nauseous, and because if you ever try to actually look through something in VR at low frames, it makes your head hurt. It really does, right? So just keep that in mind. The other thing is, a nice one is this stat here. If you go to stat, engine, and detailed, look at that, right? So you can take a look at all these other things, the amount of time it takes to basically draw each frame, you know, how hard the GPU is working, how hard the memories, how much memory you have allocated, all of this stuff. All this stuff is very useful. The other thing, which is nice, like tech artists and developers, you're going to get assets from 3D artists, and 3D artists is like, I'm going to make the best asset in the world. I'm going to make it with an 8K texture and all these polys. And then you're like, dude, calm down. Like it's a huge hit on performance. So what I did was I went to Windows Statistics, right? This statistics will let you know, hey, the most complex object that we have in here is this plant, our plant model. And it's we have 2 actors of these plants, and they're about 8,000 tries. Where are these plants? Right here. So foliage typically is a little bit more expensive. Okay, it's this one. Not bad, right? So seriously, not that bad. Like everything else is couch. Everything is pretty much really low poly. Like nothing over here screams like, oh my God, this is way too much. You can also go from primitive stats to texture stats, right? Now look at this. Now you're like, oh man, look at all these couches. Look at all these textures, right? A lot of these are 4K textures. Do they need to be 4K textures? A lot of these are 2K textures. Do they need to be 2K? If you're doing rendering in nice images, yeah, no problem. If you're making games or you're making a real-time application where performance matters, load time matters, this is where you want to be checking your statistics in your models and the impact on all of this. Okay. All right, so I just basically went through these two slides here. We have collisions. Yeah, because what we may end up, I'll keep going to LODs, which is going to be really important. Okay, so if I go back now, if you obviously don't want this, you can just do disable show stats, go to the engine. And just toggle those. And yeah, so I'm going to go to demo map here, and then I want to disable show stats. Cool. So the one thing now, right? Let me know if you guys got any questions or whatever. It's fine. But I'll keep moving. Is level of detail. Okay, level of detail. You guys just kind of saw me quickly. Like you can create lower versions, lower poly versions. Like if I go to this reduce and lower it, like 20 or something like that. Well, that's gonna break the mesh, but because I changed a lot of stuff. See, you see how this is 1200 now. Previously it was 2000, and then if I go to the reduce, I mean I can set this even lower, and now we're at about 6000. I mean the original couch here is about, if I look at my statistics here, 6600, which again is not that bad. All right, but optimization, right, is important. So we can take a look at things like level of detail, and creating a level of detail on these models. So if I grab this couch again. This is probably one of my favorite things. Like when I found out Unreal Engine had this, I was just like, are you kidding me? It's this easy? Like you can make your LODs in Max and Maya, but don't. Like don't, because let Unreal Engine do it. It's so good. It's so good. So let's do it, right? What we want to do, you can see right now, this is important. It says LOD 0. If I zoom in and out, look at that. It doesn't change. Nothing changes, okay? But if I go here to LOD, it's set to LOD auto, or I want to kind of scroll down here. And we need to change the LOD settings from LOD group from none to, hey, what is this? Is this a high detailed prop? Is this a large prop? Is this a small prop? I would say this is a large prop. So go ahead and do that. And it's just going to say, hey, we're going to overwrite this current settings that you have for LOD. So if you had imported LODs, it would overwrite that. Cool, no problem. Do your thing. Boom, done. Hey, it's done. Look at this. You may not notice what's changing. It doesn't look like anything's changing, right? That means the LOD is doing its job. Look at this number right here. These triangles. 6600. Watch this. Zoom out. 3300. Half the amount of triangles. Zoom out further. 1600. It just created these LODs on this model for us and set up this based on what's called screen size. So look at the current screen size. What this is saying is this model is taking up, this is 100% of the screen, right? Based on these bounds. If I zoom in further, it's like, oh yeah, this is way too close. This is about 80% of the screen, 50% of the screen, and then it goes out. Right? So what can I do? I can change this. Okay. So just to make sure that you can actually see it, it's actually hard to see it. Watch this. Look at the geometry here. Look at this edge, these edges. Zoom out. And then now, look at that 3. Look at it pop back and forth. You only see that in the wireframe because I'm showing wireframe. LODs don't destroy UVs. It maintains UVs actually and all of that. So the one thing that you want to do is this here, auto compute LOD distances. That's the setting that we want to change. So if I actually go down here, auto compute LOD distances, which is based off of screen size. Okay. And then I can go to here, and I can go to LOD1 under the LOD. You can change the screen size. So if I go to screen size here, LOD0, we have LOD0, sorry, it's right here. So if I go to LOD1, LOD0 is the original mesh, okay? LOD1 now is the first one that's decimated. And what this is saying is, hey, at 90% of the screen here, size, we're gonna swap it out. So I can say, you know what? Wait until 50% of the screen or 60% of the screen. LOD2, oops, LOD2, so under the LOD picker here, LOD2, I can do 0.25, LOD3 is gonna be 0.15. So all I'm showing you is just a way to have control over when that LOD pops in and out, okay? And once I'm done there, I can go back to auto LOD. Now watch, at 90%, it's fine. It doesn't pop. It doesn't change until I get past 50%. Boom, 50%, 3300. All right. This gives you absolute and complete control over your LODs. The other thing is, which is incredibly powerful, right? I wish, again, Unity had something like this in engine, but it doesn't. You'd have to manually create them, use Maximize. It's just so much more to handle. So it's a fantastic thing for Unreal Engine to include that right in the engine. All right. So if we go here, take a look at the PDF, level of detail meshes. And again, the reason to create LOD, the whole reason is to help with performance and runtime performance. If I'm here and I'm in a larger, like we're in a small environment right now, but if I was in a much larger environment and I had couches all the way over there, you better believe I don't want those to be full resolution couches, you know, sitting there in the camera, okay? So very helpful. It takes just, you set it up as you go and then you move on. All right, the next one is taking a look at collisions, right? So if we take a look at collisions now, and the one thing I want to do is actually go ahead and I want to actually start importing some more assets so you guys can start building for this workshop. So we'll start on collisions, materials, textures, and we'll cover that in the next one. So it's not a big deal. It's not a requirement for the workshop. So what are we going to do for workshop time now, right? What I'd like you guys to do, so I'm actually going to go ahead, delete these here, because I did all sorts of things. I don't remember what I did to it. Is if you have Maya, you have this open, I highly encourage you to go through the process and import a few of these assets, okay? Or I'm sorry, export a few of these assets outside of Maya, okay? Because we want to build that. We want to build this in Unreal Engine. Then in Unreal Engine, start bringing your assets in, right? So if I go to this demo folder, you can start exporting them into this folder here, or just completely fine if you want to use this balcony here, all right? So one thing to keep in mind, so if I go ahead, you can actually, like if I grab all my books, all my structures, that's going to be important. All my books, my structure, and all my shelves. Just for now, just so you can kind of see me import a bunch of resources. Books. And you can see that I have them broken up in 5 sections, right? So I have my books, my shelves, which all my books will sit in, and structure. I mean, you're going to want to do basically all of them, but I want to just show you a good handful for the sake of time. Simply go ahead and just drag that right into that FBX folder. And remember, some of these, I would say just go ahead and do combined meshes. Okay, some of them you're going to say, actually, I want to move them separately. And the nice thing is we have a bunch of meshes we're going to do. So I'll do import all. And let it run. Okay, this isn't too complex. There, a good handful of assets. It took it a few seconds. Under details here, there. Now, this is why organization is important, right? Except this one. I forgot to put the T on the T normals books. But let's just go ahead and drag all of these books and everything within this scene here. Boom. Okay, look at that. Now, here's what I said the transforms are important. We're basically going to import this with zero transform. So reset these to 0, hit this yellow box, this yellow arrow. I can obviously delete this. I don't need that anymore. And there you go. We're starting to get everything set up in our scene. Now, here's one thing we're going to cover here in a little bit is that the materials. Okay, so look at this wood floor material. We're not going to cover how to make materials. It's out of the scope for this workshop. But if you go to the ArcViz folder here and go to materials, you can basically find M wood floor mat instance. So in this case, there's an M wood floor mat, right? So I'm going to want to find actually, remember our naming convention. So M underscore wood, there it is. M wood floor instance, M wood floor instance, grab that. Boom, there it is, right? So what I'd like you guys to do for the next 30 minutes is start to bring in your assets. Make sure that they're in the right position. Make sure orientation is good. Start applying these materials, right? And then in this ArcViz materials folder, there's M shelving, right? And then there's M shelving instance. Then we can drag that. And this is kind of this dark tarnished wood here. And now the books are interesting. I can select all these books. They're all based off this M book instance. So if I look at M book instance, boom. Look at that. So we can start to apply those materials, and you can see that they change. They have some variation to them based on the UVs of the object. That's how they're changing colors. I can see, oops, I have this one just floating here, right? I can go back to my FBX folder, and I can right click. Hey, let me use right click import. Let's bring in my coffee table. So this is workshop demo. I want to go to the ArcViz room, exports, ArcViz. And I want to bring in my coffee table. So coffee table, import with these settings, import all. Now remember, if you didn't have combined meshes, all these books would have been separate objects, and this would have been a mountain of assets. Boom, drag that in there. You can this is already on the origin, but go ahead and reset that transform. There you go. Then back to the materials here, we want to apply the M coffee table. So if I go M underscore coffee table instance, there you go. Look at that. It's this nice wood and metal. All right. So that's really what we're doing. We're just practicing bringing in our assets. We're practicing importing them. Oops, I hit the mic. Practice importing them. And then, of course, once you get a good few assets in there, go ahead and, back to your FBX and create some LODs. Maybe move the pivot so you're comfortable with how to adjust the pivot. You also don't have to keep these exactly in the same position. You can do whatever you want, right? The last thing that I wanted to bring up, I can hit Control S here, is to understand there are building environments outside of Unreal and then bringing them entirely into Unreal Engine. If I hit Control N and actually do a quick default and look at these meshes here, if I grab all of these meshes, look at this. All of these meshes here are where? On the origin, right? because this environment was imported and then built. Let me just hide that or delete that, right? The reason for that is so the level designers, the artists create the assets and the props, and the level designers actually say, okay, I got this couch, and this is the floor plan. All right, I want to position this couch here, and everything's based off the origin. Okay, so I don't want you to think that one way is better than the other, but you can certainly do both. It depends. If it was me and I was doing it solo, I mean, I typically just build it all out in here and then export, But if it was more of a pipeline and I was but if I was a 3D artist, yeah, I definitely want to focus on creating these props, making sure pivots and everything are all set up. There's the door, and actually this door goes on the other side, and then rotate it. I feel like I need to rotate that door. Yeah, it's facing the wrong way. There you go, 180. We move the curtain over here. So I just want you to understand there's different ways to do this, and the way that I'm showing you is, I want to show you both ways, basically. Okay. So, like I said, what we're going to do is I'd like you guys to start this right here. Export as FBX, import into Unreal Engine, or just use the exports that I already provided, which are all of these. And start importing into Unreal Engine. Start building a level. All right. And, keep all the best practices in mind and just recreate it in a new level. If you want the closer lighting, I did make another level here. I don't need this anymore. I can go to room start. If you literally want to just drag and drop them into a setting, oops, I meant to type it down here. If you want to just use room start, everything's set up here. All the lighting, all the reflections, you can use this to do that, or just use a demo map. I mean, either way is completely fine. All right, yeah, workshop time. So let's do this up until 12-ish o'clock, 12 o'clock, and then we will take a break at that time. So from 12 to 1, we'll just take a break, and then we'll get started at 1. I'm going to be here till 12 o'clock. So ask me questions. Yes, it's pretty quiet. It's all right. If there's anything that I did along the way, or if you start to import assets and you're like, hey, I tried to do that one thing that you did and didn't work. Can you show me? Or share your screens, whatever you want to do. So go. That makes sense, guys. I need one person to give me some sort of affirmation here. Like
that makes sense to me.
All right. Thank you. Cool. Get to it, guys. Let me know. Okay, so we're just going to continue on where we last left off. We just wrapped up understanding level of details, and then now we're going to take a look at collisions and, really whether or not you're going to need them. Okay, so the thing to understand when it comes to collisions is if you're just using Unreal Engine just for rendering, if you're creating nice images and walkthroughs and animations, no, you're not going to need collisions, right? Because you have a pre-scripted camera and you're not going to risk going through any walls or any objects. But if you have an interactive walk around, if you're going to have people, users just walking through your environment, if you're doing VR, if you're creating a standalone application, you're definitely going to need to keep them within the bounds of your world and the bounds within the level, okay? And you want to make sure that they can't go through geometry, all right? So for example, if we take a look, so I'm going to save this demo map here, and if I go to the room that we have, and I go ahead and hit play, you'll see that I can kind of start walking around, and I can walk to the wall, and I can't clip the wall. I can walk to the end here. and I can't walk through the balcony, right? So you're pretty much just bound to here. You can't even walk over this this coffee table. Okay, so if I go and take a look at this, you can see how it's set up. Now, one easy way to view collisions is if you just go to the view mode here and enable player collisions. So you can see this how it's currently set up, right? Obviously, right now, Unreal Engine just has basically these what's called blocking volumes. Blocking volumes are nice because they're essentially just invisible walls that just keep players and users bound within a specific environment. And you can go here and change the shape, change the size, and change the primitive shape here. So if I wanted to do maybe change it to some sort of cone or some sort of mountain, you can. If you wanted to do, well, yeah, then you have the cube, which is the box, and then a cylinder, and you can change the size here, which is basically what is being used. Let me go ahead and undo that. Okay, and that's what's being used here, right, for these cylinders, right? And if I go back to lit mode, you can see that, oh yeah, that makes sense. I don't want to clip through or walk through the lamp here or the shelf or the bookshelf. Now, the good thing is, in this case, we have all these props for our books. We don't necessarily need to create collisions for all of these books, right? Like, we're not going to be, if you can't go through this shelf, you can't go through the books, right? So that's one thing, a good thing to keep in mind. You can see that basically we just have this coffee table here, just from, let me go to player collision, and boom, you have the coffee table, your couch, and all of that. All right. So if I go back to lit mode and I go back to the demo map, so keeping that in mind, right? I'm going to actually go ahead and import now the couch. So we're going to have two of the couches, right? So we have a chair, which is the single-seater couch, and then the regular couch. And I'll go ahead and just import all. And remember, just like last time, if we go ahead and just drag these into the scene, oops. There we go, and drag these into the scene, and go ahead and set those transforms to 0, and you can just reset to default transforms there. Boom, they just pop right into place. Okay, now they're kind of looking pretty ugly here with these leather textures. So what I'm going to do is, select the couch. I'm going to go to this materials folder, and I'm going to grab that MI couch, right? Remember, we're not grabbing the master material. The master material is not going to look good either. So we want to make sure to grab the, where is it here? Basically, remember what we said about naming, right? So we can do MI couch, and there you go. So we don't have to spend a lot of time searching. And there. Now, we're going to get into material stuff, so you'll see why this looks a little bit better. And then we have this one here as well. And there you go. So we have nicer looking couches here. All right, so we've assigned those materials there. And we have our shelves here as well. I can select shelves 1, 2, 3, 4. And if I look at these materials, I can display these if I'm multi-selected materials. And I'm going to want to grab this shelving instance material and apply that to all these materials. Oops, grab the wrong one. There. All right. So we have this kind of dark, nice tarnished brown there. Okay. And basically here, if I simply go ahead and hit play, now this is just using the standard player level. I can just bust through these walls, right? I can bust through these walls and go wherever I want, which we don't really want to have in this case, okay? So you can, again, use a combination of things, right? So if I grab these, I'm going to just grab my environment and just call it environment geo. And with this now, oops, I can go ahead and take a look at, setting up collisions, okay? Now, there are some things you can do, right? So this structure wall here, if I go and find this mesh here, you can create a collision on each object. Okay, so if I go to collision here, right, just like we can view UVs, we can view pivots, we can view the mesh and wireframe, we can view collision. So if I look at the simple collision here, you'll see that there's nothing, right? So what we're going to want to do is go to collision and then do a add box simplified collision. And there you go. So this is just going to give us a nice simple collision. And we don't need all this extra detail, right? We basically just want to make sure that you can't go through this wall, right? So I can hit OK, or sorry, I can save that there. And then I can take a look at doing these for the rest of the walls here. So you can see we have the one at the front. Now this is going to be a little bit different, right? And I'll show you. I'll show you why. Maybe I'll grab the structure 5, and we'll come back to this one. Okay. So here's our wall here, and remember there's backface culling. All right. And what I can do is same thing. I can go ahead collision and add a box simplified collision, and it gives us a nice simple collision here. And I'll go ahead and save that. So now if I go back to the level, you know, we take a look at player collisions, you can see, all right, we got basically, we're starting to add collisions, right? We're starting to add it up to these 2 walls here. So if I go back to lit mode and go to play, and this is just our level, boom, look at that. I can no longer leave this, but of course I can leave the other side of the environment, okay? So you can definitely do that using just generating collisions in your environment. The other thing is you can use, again, what's called those blocking volumes. Sorry, blanked there for a second. Blocking volumes. So if you just type in block, you see blocking volume, boom. Now I can grab this in here, and this blocking volume is essentially just going to be an invisible wall, and it's going to be what we're going to want to use, you know, or you could use this instead of just, you know, doing it on a per mesh object or on a per static mesh object. And sometimes that's fine, right? I'm just kind of show you different ways of doing things. So I can do maybe 600 here in the X and in the Y. Don't forget Y is going to be our depth here. I'll maybe do 1200 or something like that, or 1000 here. And then Z is just going to be a nice, you know, ground level here. And then if I go to, you know, again, just check player collisions, there you go. You can see it now. You can see that there's a ground collision there. And then I can go back to lit mode, go to play, and now you can see, boom, I cannot go through the ground anymore. All right. And of course, you know, if you wanted to, there are ways to get more complex collisions. So if I grab this couch here, this SM couch, we can go ahead now and set this collision to collision. Again, if we used a simple box, right? That's about as simple as it gets. But sometimes you may want it to be more, if you want it to be more complex, I'd use these DOP here. And what these do, just give you a little bit more detail. Okay, now one thing to keep in mind is that these are convex. Okay, not concave hulls. All right, which means that they're never gonna go, they'll always kind of stay out like this. They'll never go inwards like this. In that case, you have to create kind of multiple hulls, collision hulls to get more detail. Because like, I'll at least show you, right? So there's auto convex collision, and you can actually, what I want to do before I do that is delete, remove collision. So we have nothing, and then we have convex, and then we can go ahead and hit apply. So here's this. So using this, again, I used auto convex collision. It'll kind of just try to do its best to create a much more complex version of this hull. Sometimes you need that, sometimes you don't. But in this case, we definitely don't need this level of complexity. The other thing is, you know, if I remove this collision and apply maybe a more detailed version of this DOP, 26 DOP, that'll work. You could bring in your own collisions if you wanted to just literally just create just kind of a simple form to go around here. All right, but I will just keep this. So I'll remove collision on the couch, and I will just add a box, save that, and then I will also grab the chair, the static mesh chair, and I will grab collision and just do a nice simple box. And you can see there's a little bit of a rotation on here because of that. So this one we actually may want to just use the bounding box or the blocker, right? So if I remove collision on that one, I forgot we had that on rotation, right? And I can use the blocking volume and get that in position. So you can see where you can kind of mix and match these here. And you can freely rotate this and not have to worry about messing with pivots or anything like that. So you do that, and you can bring these down to 100 by 100 by 100. That should be good right there. All right, and if they're clipping, that's fine. This is fine. Let's just test this real quick, and boom! Look at that. We can't go through the chair anymore. Okay, we can't go through the couch, and then, you know, last one, just for measure, is we want to grab this collision and do a add box. Boom, done. All right, and we can take a look at this scene that we're building here, and you can see that now we have all of these collisions in here, using all different methods and different ways of doing this. All right. So that covers the collision section. Let's go to the next one, which is going to be a real quick one, which is just going to be materials. I kind of covered this a little bit, but basically, when it comes to materials inside of Maya, 3ds Max, you want to just use standard materials. Now, by standard I mean using Blinn, Phong, Lambert, anisotropic. If I go here, you can see this material here, and I hit Control-A to open up the attribute editor, and you can see that the type is Phong. All right. Now I have V-Ray installed on my machine, and I can, certainly set up a V-Ray render. This is a V-Ray rendered scene, but you can't use FBX to convert V-Ray scenes. You need to use Datasmith, which we're going to be covering here in a few minutes. All right. The other thing is multi-subobject materials are supported. Multi-subobject just means you can have multiple materials per object. So if I have this, right, and let's just say I wanted to assign a new material to that for whatever reason, and it can have a different color. I probably won't use green because green means broken in Maya. And then there you go, right? And then once you come in here, you would have, multi-subobject materials. Instead of the one, you'd have element 0, 1, 2, 3, and then go that way. Okay. So the other thing is you can see that basically this imported with a material that looked like this, right? But that looks a little bit off, right? Like, take a look at what's happening. We're losing the metal and everything. This comes back to our Unreal Engine materials. So if I go to this specific material, and you can see this is what's called a material instance. We have the material instance, and here, this is a set of materials where I can apply a base, textures, normals. I can apply leathers, masks, all sorts of information. Well, where is this coming from? Right? Where is this coming from? This is all coming from this here, which is called our parent master material. So if I find this material here, it's called, it's just, that's what the difference between M and MI is. You have your master material node, then you have your material instance node. And if I opened up now the master material node, now you're going to get into this node based graph here inside of Unreal Engine. Okay, and if you've never seen this before, don't worry. I mean, we're not going to go in very deep here, but I at least wanted to show you basically how materials are set up. So you can see again, using this node based system, there's all these interesting nodes here that and graph based system that are compiling to create our material instances, right? So this one you can see it's just using a bunch of what's called parameter nodes here. And lerp just means linear interpolate. And so it's taking those and interpolating between these two values. And it's kind of doing that a couple of times, lerping. And this is used to get a nice fall off for roughness. And then you can see you can plug in your textures here with your texture samples. Okay, now you'll see this weird looking clown pass looking thing, or this like this red, white, or not red, white, red, blue, and green RGB colors. So if I go down here, let me try to see if I can find one if under textures. So they're going to kind of look like this. This is the mask. This mask, right? So now if I actually take a look at the next slide, because now we're getting into textures, right? These materials are based off of mask maps and basically, you know, what's called pack maps too. That's what I meant by, like, at the beginning I was talking a little bit about the naming conventions. You saw one that was called MRAO. That's metallic roughness and ambient occlusion. And those are all put into the RGB channels. So you have red, blue, and green here. And again, I'm going to try to just keep this high level. So you can see each part of this red, blue, and green channel within this target image is a different part of the object here. That's how we're able to have this all on one material here and still have two different materials applied, because it's using this mask. This green here, that's it's using that to mask off that part of the metal legs and keeping it separate from the leather couch. Okay, so materials and textures definitely is something that can be looked at into and probably a later workshop, and that an entire workshop can be devoted to that, right? But the last thing I wanted to take a look at is the textures themselves, right? Because remember I was talking a little bit about now we're looking at, let's take a look at some of these normal maps, right? So if I grab like N cloth D, N cloth N, you know, and we take a look at these, and we'll open it up in our texture viewer. This is the texture information. When you import these, you can import them with the models, or you can import them separately. Basically, in our exports folder, remember, or not in the exports folder, but in our Maya project folder, I have all of them here. And these are the source images. You could basically just bring all of these in and then manually relink them, because you're going to have to sometimes do that anyways, depending on your material node and your material graph. All right. So you can see you always want to make sure, let's start with the diffuse color, is always going to be compressed, right? And you want to make sure just use the default compression settings here. And a key thing in mind to keep, in mind is that you want your images to be a square power of 2, meaning you want, you know, 512, 1024, 2048, 4096, 8192. Right? The max resolution is 8192. And the reason why you want powers of 2 is because you know how we had model LODs? By maintaining powers of 2, it allows Unreal Engine to create what's called MIP maps. MIP maps are essentially LODs for textures, and they're automatically created. All right. So it allows, you know, depending on how far away you are from the model, it'll automatically, through texture streaming and texture loading, is swap out that texture to kind of keep a nice high level of optimization throughout your scene. Okay, it obviously is hard, you can't really notice it, it kind of does it in the background, but it only does it in the background if you're at a power of 2. Here it tells you number of MIPS, 12. So it has 12 basically levels of MIPS here baked into this texture map, which is impressive. So if you wanted to also, right, you can see that this footprint, memory footprint, it says resource 2700 kilobytes, which is 2.7 megabytes. If we really need to go through and, you know, we're like, oh man, we're over our texture budget, we got to clean things up. Well, the easy thing to do is take a look at your textures and your high-res textures and say, okay, if this is 2048, Well, let's just set this maximum to 512. There. And then now we took that from 2.7 megs to 170 kilobytes. Like that is an incredible savings. And then you can hit save, and you can take a look here, right? Like you can take a look at what you're doing to this cloth. Oh, actually, this is cloth, so this would be on our drapery or our curtains, right? So let me just go ahead, quickly open up that level, and we'll take a look at those specific pieces here. And I'm going to zoom in. And there it is right there, right? So we can get in pretty close here, and we can see, I'm going to set this. I'm going to try to do this, adjust my real estate a bit so you can kind of see me change these values. So if I change this back to 2048 and hit save, did you notice any difference at all? Barely. Yeah. There's barely, changing these texture sizes. Let's say obviously if I hit 64, now it starts to get a little bit blurry. Now it's starting to look a really low resolution. So obviously you don't want to go too low, but you want to maintain a good level of detail and a good level of optimizations. And you can do that right through here. There's also, again, the default compression settings here. Sometimes you can go through and do more aggressive compression, but honestly, the default BC1, BC3 on DX11 is plenty fine. I haven't had to go through, unless I'm doing mobile development. Mobile development is going to have more aggressive compression, but that's fine for now. Things like normal maps are a lot heavier. Okay, so these now, the other one was 2.7 megs, this is 5.4, right? And the thing is that it's no longer, there's no color correction setting, so this is sRGB disabled because you want the raw color of your normals, otherwise things won't look right. So this is kind of the same thing, if I set this to 512 to get 170 kilobytes, save that. I'll go to my cloth normal here and expand the texture. The texture over here, and I also set that to 512. And we can save that, and there you go. There's almost, because these are being tiled, right? So I would take a look at any tiling textures and definitely reduce the resourcing there. You can see that it lowers the number of MIPS too. All right, let's see any other points here. Yeah, these are just all the supported ones, BMP, PNG, TGA. I would definitely rely on TGA target images because that gives you the RGB channels plus alpha as a separate channel. When you're getting into mask maps, packed maps, you definitely are going to need those 3 to 4 channels to get the most efficiencies out of your textures. The reason why is because RGB, metallic roughness and ambient occlusion are all grayscale maps. And those grayscale maps can sit in each individual color channel here, and that saves an immense amount of texture memory. So instead of having 3 separate grayscale maps, you can have one that has all those packed into the channels, which we can get into later. Here. And textures are automatically imported if linked with the materials, but you can also import them separately, which I talked about. And then we talked about the powers of 2s and max resolution and alpha. Okay, we hit on this. I just wanted to make sure, just kind of watching out for the following, watching out for bad normals, watching out for Z fighting, Z clipping, and stuff like that. Z fighting, Z clipping sometimes is when you have like really thin pieces of geometry, or geometry that's right on top of each other, or multiple materials that's on top of each other. It's basically like Z depth. It comes from the Z buffer. So they're basically fighting over who has priority. So you get this weird clipping happening. All right. And the last thing I had, yeah, incorrectly scaled objects, which we talked about, and then making sure that you don't combine too many objects with each other. Don't just like select a bunch of random objects, combine them, and export them. It's just going to make your life a lot more difficult. So just keep it modular, because that also helps what's called visibility or occlusion culling, which it'll Unreal Engine will disable or turn off objects that are not in the camera view. Okay, so great. That was the last bit. I didn't want to rush that in on the last workshop, or last bit of the workshop, so we can answer any questions before moving on, and we can get into the next module here. All right, that concludes the recording for this specific module. Be sure to check out the rest of the modules in the description. And if you found this helpful, please let me know down below. And definitely plan to put out more Unreal Engine and Unity and real-time 3D content here in the near future. So thanks and take care, everyone.